Hour. My name is Mr. Isasi, Albert Isasi, and I'll be doing today's presentation on trigonometric graphs. This section, this workshop covers only chapters 4.5 and 4.6 because it's too much information to cover in 50 minutes. So I'm going to concentrate on just graphing. The most important graphs that you need to know is the cosine and sine graphs, because the secant and cosecant depend on you knowing how to graph the sine and cosine. So more than half of the workshop will be on graphing these two graphs, the sine and cosine. So today's objectives is graphs of sine and cosine functions and graphs of other trig functions such as tangent, cotangent, and cosecant and secant. Okay, now this is like the parent function of the sine graph, and this is the parent graph. So everything that has to do with sine is related to this graph here. If you notice, this is called 1 period, right, which is 2 pi. Most of the times for the homework and also in the book, they want you to graph 2 periods, which will be a total of 4 pi, right? Because from 0 to 2 pi is 2 pi, and then from negative 2 pi to 0 is another 2 pi. But for the sake of simplicity, I'll be graphing only 1 period. Okay, and if you notice 1 period, right, then it continues on the same pattern. Okay, now what do we need to know to graph? Okay, we need to know the amplitude, which is how far the graph goes up and how far it goes down. Okay, now this is the general form of the sine function. Y equals to a sine of bx. The a, guys, is the amplitude, which means how far the graph goes up and down. And the period, right, 1 period is 2 pi over b. That's why it's crucial to know what the a is and what the b is to be able to graph. And also you need 5 key points to graph 1 period. For example, you see this is the first point, which is 0, 0. My second point will be pi over 2, 1. My third point will be pi 0. My fourth point will be 3 pi over 2, negative 1. And my fifth point will be 2 pi 0. So these are the 5 key points for you to be able to graph 1 period. Every graph every trig function, when you graph it, needs to have those 5 key points. Okay, so I'm going to show you how to find those 5 key points. So now let me prove to you guys by all these formulas and stuff why the sine graph looks like this. Okay, how it is here. So I'm going to sketch y equals to sine of x from scratch, right from the beginning. Okay, so right away, right, so we have to know what the a is and what the b is to graph 1 period. So here, guys, my a is equal to 1, right, because there's no number or there's no coefficient in front of sine, right, so we know it's a 1. My b is also 1, right, because there's no coefficient in front of x, so we know it's 1. So then I need to find my period. My period will be 2 pi over b, right? My b is equal to 1, so I'm going to plug in 1 for b, which will be 2 pi over 1, which will be 2 pi. Now here's how you find the 5 key points. Okay? The sines, both of them start at 0, the sine and cosine, so we're going to start at 0. Okay? But before that, I need to find, right, the other point. So we're going to get the period, which is 2 pi, and divide by 4. You always divide by 4. This is always a formula. Period divided by 4 to get the 5 key points. So we have 2 pi over 4, which will be pi over 2, which means we're going to be counting by pi over 2, but we have to start with 0. So we got 0, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Now let's go back and simplify simplify each one of these terms. That'll be 0. It cannot be simplified. That'll be pi over 2. That'll be pi, because 2 pi over 2, we'll just give you pi. 3 pi over 2 stays how it is, and 4 pi over 2 is equal to 2 pi. All right? So now, how do we know, what the points are? We know, right, we have to know what the sine and cosine of 0 are. So we know that the x, right, the point xy is equal to cosine and sine. So right now, we're going to be graphing the sine wave, right? Or the sine curve. So what's the sine at 0? Remember that the sine of 0 is going to be the y value, which will be 0. That's why it's 0. My second point, the sine of pi over 2, right? At pi over 2, my sine is equal to 1. That's why at pi over 2, we have 1. My third point, right, will be pi. The sine of pi will just be 0, so it'll be pi 0. Number 4, the fourth one, right, will be 3 pi over 2. The sine of 3 pi over 2 is equal to -1. That's why the point will be 3 pi over 2, -1. And finally, the sine of 2 pi will give me 0. So the point will be 2 pi, 0. So these are my 5 key points to graph one period. Okay, here we go, right? So this is how it is, right? One period. So my first point, right? My amplitude will be from -1 to 1, right? That's my amplitude because my A is equal to 1. So my first point is going to be 0, 0, which is right here at the corner. My second point will be pi over 2, 1, which will be that point right there, which is the maximum. The next one will be pi 0. That's my third point. And my fourth point will be the minimum, which will be 3 pi over 2, -1. And my last point, the 2 pi, it will be 2 pi 0. You see, guys, that's how we sketch the sine wave. Okay, now. Now, I know this here, guys, this one, we're not going to graph it. We're just going to practice to find the 5 key points. Okay? And I believe if you follow this method that I'm going to show you guys, you can never go wrong. Because at times the equation looks kind of crazy. Like, for example, this one looks kind of crazy. When I was in school taking these courses, I used to freak out when I would see something like this. But after I learned how to explain it, it's not that complicated. So I'm going to show you. By repeating the process that we did earlier. I need to find my A. Right, the A is the absolute value of 1/4, which will be 1/4. So my amplitude will be 1/4. My B is 1/6. I use the B to find because the period is 2 pi over B. So we have 2 pi over 1/6 will give us 2 pi over 6 over 1, which will give us 12 pi. Now, right, so my amplitude is 1/4, and my period is 12 pi. So now we need to find the 5 key points. So we divide the period by 4. So the period is 12, so 12 divided by 4 will give us 3 pi. So we're going to be counting by 3 pi. Okay, so we start with 0, 3 pi, 6 pi, 9 pi, and 12 pi. Now, if the 5th point, right, is not the period, it means we did something wrong. So this is how you can check. If we have the same, all the same points here. Because all this means that every unit, right, like a time with, right, like we start with 0, 1, 2, 3, 4, and so on, right? Everything has one unit, right, of space. Here, guys, everything is going to have 3 over pi of space. So every unit will be like 3 pi. Okay. And again, we're not graphing it, right? We're just trying to find the 5 key points. So, hey guys, the sine wave has key points. They always start, for example, right, if it starts with 0, it'll be 0, 0, right? And then that was the one from before. The one that we just did. We had pi over 2, amplitude, pi, 0, 3 pi over 2, negative amplitude, 2 pi, 0. In this case, guys, right, the points from the previous slide were 0, pi over 2, pi, 3 pi over 2, and 2 pi. But here we got 0, 3 pi, 6 pi, 9 pi, 12 pi. That means my first point is going to be 0, 0. My second point will be 3 pi amplitude, and the amplitude will be 1/4. My third point is going to be 6 pi, 0. My fourth one will be 9 pi negative amplitude, which would be negative 1/4. And my last one is going to be 12 pi and 0. Again, these are the key points. This is a key. The key points that we find by dividing the period divided by 4 are the x values. The y values will always be in this form: 0, amplitude, 0, negative amplitude, and 0. Okay, so please be aware of that. So these are my 5 key points. Okay. Now let's go back and graph y equals to negative sine of x. What happens when we graphing instead of graphing the sine of x, it's negative. So my amplitude, right, is negative 1, which is the absolute value of negative 1, which will be 1. My b is also 1, right, because the coefficient of x is 1. Now the period will be 2 pi over b, which will be 2 pi over 1, which will be 2 pi. Right? So to find the 5 key points, we divide the period, which is 2 pi, divided by 4. So it'll be, right, then we reduce it, it'll be pi over 2, which means we're going to be counting by pi over 2s. We start with 0, and then pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Right? Now, right, we simplify. We got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, from here, guys, okay, we're going to find our points. But we have to go back to our circle, okay? This is similar to the one that we did, graphing the basic y equals to sine x. Okay, now, again, the x and the y is a cosine, and the y is my sine. So the first point is 0, 0, right? My second point is pi over 2, negative 1. You'll be saying at pi over 2 is 1, not negative 1, but here's why is negative 1, right? If we plug in pi over 2 here, right, the sine of pi over 2 is equal to 1, but with a negative in front of the sign, we'll make it negative. That's why it's negative. At pi, right, is going to be 0. At 3 pi over 2, right, we know it's negative 1, because sine of 3 pi over 2 is negative 1, but negative and a negative will give you the positive. And at 2 pi, it's going to give us 0. So these are my 5 key points. Okay, now, how do we graph it, right? If you notice, it's going down instead of up, which means when the a is negative, it's going to go, it's going to reflect on the x-axis. If it's positive, right, it's going to go, like the normal graph that I did on the first slide, on the second slide. Now the negative is going to be going down to start off. So we start with 0, 0, my first point. Pi over 2, negative 1. We got pi 0. We got 3 pi over 2, 1. And we have 2 pi, 0. That's how you graph the negative sign. Okay, now, again, hey guys, we're just graphing, right, just one period. But remember, guys, the sine wave keeps going forever and ever. Unless you set a domain. Okay, for example, right, this point here is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and it keeps going, right, and to the left will be negative pi over 2, negative 3 pi over 2, and negative 5 pi over 2. You see, and again, it just keeps going, the sign keeps going in the same pattern. But here, guys, we're only graphing one period, which means we're graphing from pi, right? If it's 2 periods, we're going from negative 2 pi to 2 pi. But like I said earlier, we're only graphing, one period to simplify it. And then all you do, to graph the other period, all you do is continue on the same pattern, right? Okay. Again, right, we're only graphing one period, which is 2 pi. And this is my 2 periods. Okay. Okay, now let's sketch y equals to 3 sine of 2x. Okay, now, again, what's my a? My amplitude will be 3. What's my b? Is going to be 2. So what's my period? It will be 2 pi over 2, which will be pi. which means the period that we're graphing is going to go from 0 to pi. Okay, now, but we need to find the other 5 key points. So how do we do it? We divide the period by 4. So pi divided by 4 will give us pi over 4, which means we're going to count by pi over 4. And the 5th point has to give us pi in order to verify that we did it correctly. So we start with 0, then pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and let's see what simplifies. The 2 pi over 4 simplifies to pi over 2, then the 4 pi over 4 simplifies to pi. You see, notice guys, the period matches the last point. So we know it's correct. Okay, now, how do we graph it? So this is like the normal, everything is like the normal sine wave. But with the 3, it means it's going to go up 3 and down 3. Right? And the 2, it means it's just going to be, but it has like the same pattern, right, as it is from the regular sine wave. Okay, everything has the same, everything with a sine, with the sine guys has the same, same pattern, right, or the same, wavelength, but some can be more narrow, some can be more wide, depending on the B. Okay, now let's get the points. So again, we start with 0, 0, right? That's my first point. Then this point here is going to be what? It'll be pi over 4. Right? It will be pi over 4, 3. This will give us pi over 2. That'll be pi over 2, so it's going to be pi over 2, 0. And then we have 3 pi over 4 is next. So we're going to have 3 pi over 4, negative 3. And then finally, we're going to have pi, 0. Now see you graph these. Okay? And guys, these are not that hard, guys, if you follow what I'm teaching you here. Okay? Okay, now let's do another one. And again, I'm gonna emphasize a lot on the sine and cosine. Why? Because cosecant and secant, to graph those, you have to sketch first the sine and cosine. For example, for the secant, you have to graph the cosine because secant and cosine are opposite reciprocals. And to graph the cosecant, you have to graph the sine first because they're also opposite reciprocals. Okay? So now, again, same thing as before, right? We do the same thing over and over again. So my amplitude will be negative 2, right? But the absolute value of negative 2 will give us 2, which means it's going to go up 2 and 2 down. My B is pi over 4. So my period is 2 pi over B. It will be 2 pi over pi over 4. This is the same thing as 2 pi times 4 over pi, which will give us 8. You'll be thinking, how can you? What happened? There's no radian, there's no pi. Because if the pi's cancel, don't worry about it. Just keep doing the same process. Okay, so to find the 5 key points, we're going to divide the period divided by 4, which is 8. 8 divided by 4 will give us 2, which means we're going to count by 2s. So we start with 0. We got 2, 4, 6, and 8. And again, right, the period matches the last point. That's why I know it's correct. Okay, now, so how do we graph it, right? So we start with 1, 0, and then 2, negative 2. Because remember, guys, it goes from 0, because this is negative, it's going to be going down instead of up. So if it's negative, it starts 0, negative amplitude, 0, amplitude and 0 by following the pattern that I showed you earlier. So these are my points. Now this is my graph. You notice, guys, we have 1, 2, right? The amplitude is 2, and down 2. My first point is that's 0, and then 2, and then 4, and then 6, and then 8. So at 0, right, is going to be 0. That's my first point. My second point at 2 is going to be negative 2. My third point will be 4, 0. My fourth point will be 6, 2. And the last one is going to be 8, 0. And again, right, because this is negative, is going down first, and then it goes on the same sequence. The positive, the positive graph, guys, went like this, right? It went like this, up, and then down, and then up again. Okay? But this is the graph of this particular problem here. Now, let's graph the cosine of x. The cosine starts at the amplitude. And right now, I want to show you why. Okay? And again, this is one period as before. This will be two periods. Over here is my amplitude, which will be from negative 1 to 1, the amplitude. We need to find, right, the A, which is the amplitude. We need to find my period, which is 2 pi over B. And then the 5 key points, we divide the period divided by 4. Okay? This is my first point. It starts at the amplitude. My second point, right, which will be 0, 1. My second point will be, is right there where the pi over 2 is. So it will be pi over 2, 0. My third point will be where pi is. This is going to be pi negative 1. My fourth point is 3 pi over 2, which will be 3 pi over 2, 0. And my fifth point will be 2 pi, and it's going to be at 1, 2 pi 1. Those are my 5 key points. Okay. Now, let me show you how to graph the y cosine, even though I showed you the picture in the previous slide, or the image of how it looks like, but let's do it from the beginning, from scratch. Okay. So y equals a cosine of bx, graph one period. So my a is 1, and my b is 1. And the period will be 2 pi over b, which will be 2 pi over 1, which will give us 2 pi. Now the other 5 points, we divide the period, which is 2 pi, divided by 4, which will give us pi over 2. So pi over 2, so we got 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So the 2 pi over 2 simplifies to pi, and the 4 pi over 2 simplifies to 2 pi. If you notice, guys, these are all in the unit circle, right? They're in the unit circle. They're always those graphs because this is a basic graph. Okay, so this relates to the unit circle, right? In this one, right? This will be pi over 2, pi, 3 pi over 2, and 2 pi. So now we have x and y, right? The cosine is the x and the sine's the y. So how do we know we start at the amplitude, like I showed you earlier on the previous graph? Because at 0, my cosine is 1, right? Because the x is a cosine. At pi over 2, my x value or the cosine is 0. At pi, my cosine or the x value is negative 1. At 3 pi over 2, the cosine is 0. At 2 pi, my cosine or my x value is 1. That's why the graph looks like this, right? So this is, right, the amplitude will be from negative 1 to 1 is my amplitude, right? My first point will be 0, 1. My second point will be pi over 2, 0. My third point will be pi negative 1. My fourth point will be 3 pi over 2, 0. And my fifth point will be 2 pi 1. Okay. And you notice, guys, this is a pattern for the cosine, right? Whatever point we get here, right? When we divide the period by 4, all these points are the ones that go here for the x value. And then for the y value, right? I mean, without using the circle, it's going to be amplitude, 0, negative amplitude, 0, amplitude. So that's a pattern that we'll be using from now on. Okay, now for this one, guys, it just says find the 5 key points, right? To sketch one period, right? But we're not sketching it. It just says to find the 5 key points. So again, my amplitude will be negative 3/5. The absolute value, which will be 3/5. So this is my amplitude. My b is pi over 12. So my period is 2 pi over b, which will be 2 pi over 12. Right? This is the same thing as 2 pi times 12 over pi. The pi's cancel, so the answer will be 24. So my period will be 24. Now, how do we find the other key points? We divide the period, which is 24 divided by 4. So we're going to count by 6s. So we start with 0, 6, 12, 18, and 24. Okay? So what are my key points? Again, right? This is the cosine 5 key points. is 0a, 0 amplitude, pi over 2, 0, pi negative amplitude, 3 pi over 2, 0, and 2 pi amplitude. Again, but these points here on the left, for the x values, are the ones from the parent graph of the cosine. Okay, but now we're going to replace these right here, the x values, with the ones here on the bottom here. So it's going to be 0 amplitude, which will be 0, negative 3 pi over 5. And then it's going to be 6, 0, and then 12, negative, right? Because here, right? I mean, here, right? Because it starts with negative first, because it's going down, guys, right? I mean, that's why it starts with negative, because if this is negative, you start with a negative. So this will be reversed. It'll be negative amplitude, 0, positive amplitude, 0, and negative amplitude. That's why if it's positive here, guys, it's going to be negative here because of the negative here at the beginning. So we got 18, 0, and finally we got 24, negative amplitude, which would be negative 3/5. These are my 5 key points. And to graph it, guys, all you do is make your graph and include this graph on the sine curve, and now you get a perfect sine curve. I mean cosine curve. Now let's sketch y equals to negative cosine of x. Okay. So again, right, as before, we need to know my amplitude and the period. The amplitude is 1, my b is 1, so the period will be 2 pi over 1, which will be 2 pi divided by 4. So again, guys, those are the normal or the standard x values: 0, pi over 2, 3 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, and then we simplify. We get 0, pi over 2, pi, 3 pi over 2, and 2 pi. So again, right, my x is my cosine, my y is my sine. I guess for the first point, right, because it's negative here, at 0, my cosine, I mean here at 0, right, at 0, my cosine is 1. But 1 times negative, right, will give us the negative 1. So we start with 0, negative 1. My second point, right, is at pi over 2. At pi over 2, my cosine is 0, so it doesn't matter because 0 times a negative 1 will just give you 0. So it'll be pi over 2, 0. My third point will be at pi. At pi, my cosine is negative 1. But negative times a negative will give us a positive. So it's going to be pi positive 1. And the fourth point is going to be 3 pi over 2, right? The cosine of 3 pi over 2 is 0, so that doesn't matter. So it'll be 3 pi over 2, 0. And finally, at 2 pi again, my cosine of 2 pi will be 1, but 1 times a negative will give us a negative 1. So these are my 5 points. Now for the graph, right, here's my graph. Right, it goes from negative 1 to 1, right, that's my amplitude. My first point is 0, negative 1, so this is, hey guys, it's because this is, it's gonna try to find a graph that had the pi, the radians, but I couldn't find one. So anyway, this point here is my pi over 2. This will be my pi. Here at the end will be 3 pi over 2. And here will be my 2 pi. Okay? So my first point is 0, negative 1, which will be right here. My second point will be pi over 2, 0, which will be right there where it crosses the intercept. Pi over 2, 0. My third point will be pi 1. My fourth point is going to be 3 pi over 2, 0. And my fifth point will be 2 pi negative 1. That's how we graph one period of the y equals to negative cosine of x. Okay, now comes the shifts. Okay, if you have something like y equals to a sine of bx minus c, or y equals to a cosine of bx minus c, this means it's going to be a horizontal shift or horizontal translation. Okay, for these, the left-hand point will you get the bx minus c and it equal to 0 for the left-hand point, and for the right-hand point, you let the bx minus c equal to 2 pi. Okay, but like I tell my students, you don't do the shifts until the very end. Okay, to make it easier. So let's graph y equals to cosine of 4x minus pi. So again, right, solution, again, first find the 5 key points, then adjust the horizontal translation. That's what I'm trying to tell you guys, but by doing the left endpoint and the right endpoint. For now, let's pretend it's only cosine of 4x. Okay, my A is 1, my B is 4. So my period is 2 pi over 4, which will give us pi over 2. So we're going to count by pi over 2. 0. First, right, to get the fourth point, we divide pi over 2 by 4, which will give us, it'll be pi over 2 by 1/4, will give us pi over 8. So we're going to count by pi over 8. We start with 0, pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Now let's see if which one simplify. That one's okay. Pi over 8 is okay. The 2 pi over 8 becomes pi over 4. The 3 pi over 8 is okay. The 4 pi over 8 becomes pi over 2. If you notice, guys, right, my period is the same thing as my last point. That's why I know this is correct. That's so you can check your work. Okay, now, I believe this is going to take me like 2 slides because I cannot put everything in one slide. Okay, now, my first point, right, will be 0, 1. Because remember, guys, the cosine starts at the amplitude. Then it'll be pi over 8, 0. And then 3 pi over 8, negative 1. And then, pi over 4, negative 1. And then 3 pi over 8, 0. And then pi over 2, 1. So these are my key points, okay, for the, without the translation. Right? And but remember, my first one will be 0, 0a, 0 amplitude, pi over 2, 0, pi negative a, and so forth, right? But here, guys, these, the 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2 are the ones that replace the x values on the original one. That's why these are my points. Okay. Okay, now. So this is the cosine key points, and these are my sine key points. Okay. This is the pattern here, how it is here. So now let's apply the translation, right? So these were my 5 key points without the translation. Okay, now my left hand point, right, according to the rule, you let the bx minus c equal to 0, right? So I let my 4x minus pi equal 0, so I have pi over 4. That's my left hand point. And for the right hand point, it says to let the bx minus c equals to 2 pi. So we do that, right? So we're going to get 4x equals to 3 pi. So x equals to 3 pi over 4. So from here to here, guys, it's going to be 1 period. Okay? And we can check our work right now to see if we have it right. Okay, now, so what do we do? We're going to add, right, because x, right, is a horizontal translation. So for horizontal shift, it means the x's are going to change. So we're going to add pi over 4 to every x value here. So we're going to get 0 plus pi over 4, 1, which will give us pi over 4, 1. That's my first point. The second point, we're going to add pi over 8 plus pi over 4, which will give us something like 3 pi over 8. It'll be 3 pi over 8, 0. My third point, we're going to add pi over 4 plus pi over 4, which will give us pi over 2. It will give us pi over 2, negative 1. My fourth point is going to be 3 pi over 8 plus pi over 4 will give us, I believe, 5 pi over 8. Right? 0. And finally, we have pi over 2 plus pi over 4 will give us 3 pi over 4 and 1. So these are my new points for that translation, guys, right? This is now these points become these right here. Okay, now, so how do we graph it? Okay, now, this is a normal one, right? This is a 0, 1, the pi over 8, 0, and so forth, right? But over here, guys, these are my point now because it shifted pi over 4 units to the right. You see, everything shifts pi over 4 units to the right. Okay, now we're going to start here, guys. So the graph starts here. This is 1, right? And negative 1. So this here, guys, is pi over 4. This is 3 pi over 8, right? This is pi over 2. This will give us 5 pi over 8. And here will give us 3 pi over 4. So the graph, guys, only goes from here, guys, from pi over 4 to 3 pi over 4. Okay, now, what's my first point? Pi over 4, 1. Then 3 pi over 8, 0, which would be this one here. The second point. the third point is going to give us pi over 2 negative 1 down here. Now the fourth point is going to give us 5 pi over 8, 0. And my fifth point, the final point, will give us 3 pi over 4, 1. That's how you graph this particular graph here. Again, it's easier to first find everything, all the points, how we've been looking for those, and then after that, apply the left endpoint and the right endpoint, and then you make the proper shift. Okay. Hey guys, if the left endpoint is positive, right? Say it's pi over 4, that means that the basic graph is going to move pi over 4 units to the right. If this was negative, right? If this was negative, then you will subtract pi over 4 from every x value there. That means that this graph will shift to the left pi over 4 units. Okay. Now let's add the vertical shift. Okay, the bx minus c is horizontal shift, and the d is a vertical shift. So I'm going to do the very same graph, guys, okay, as what we did right now, which was y equals to cosine of 4x minus pi, but all we're going to do is add 3. Okay? With that, guys, I'm going to get all the points because I already did the work, right? So these were my points, right? I mean, the one that we sketched on the previous slide. Now, the 3, guys, the d means vertical shift, and the y, right, the y is vertical, and the x is horizontal. So here, guys, we're going to add 3 to every y value for the vertical shift. So the first one becomes pi over 4, 4. Second one becomes 3 pi over 8, 3, because I'm adding 3 to every y value. The third one becomes pi over 2, 2. 5 pi over 8, 3. And the last one becomes 3 pi over 4, 4. Okay. Now on the next slide, guys, okay, I graphed, right? I mean the previous one, right? Which was the cosine, the y equals to cosine of 4x minus pi. This is my graph here. Now the 3 means, guys, that this graph is just going to move. Everything's going to go up 3. You see, guys, so we have 2, 3, and 4, right? So everything went up 3. And you can check this out. So this point here, guys, at the origin, it went up 1, 2, 3. The point at pi over 4 went up 1, 2, 3. The pi over 2 went up 1, 2, 3. The 3 pi over 4 went up 1, 2, 3. So then, guys, let me go back. That's how you get, how you translate it. So first, you start with a normal graph as we started from the beginning. And then for the horizontal shift, right, we don't apply the shift until we have other points, and then we add the shift to the x values. And for the vertical shift, we add whatever the d is to the y values. And then at the end, guys, all you do is shift it up or down. Okay? Hey guys, well, that's it for that section 4.5. Now comes 4.6. This is called other trig functions, graphs of other trig functions. So the first one that we want to graph is a tangent. Okay, guys, the previous ones, the ones that I did, I got them from the homework, but I just made them up. But these guys come straight from the notes, from the book. Why? Because to me, guys, it's real hard to graph some of these graphs, right? Like I mean, with animation, I mean, like I've been doing. So here, guys, all I did was copy and paste it from the book. But let me explain to you what everything means, okay? So this is the regular graph of the tangent. Okay, now, one period is pi. You see, every pi, guys, there's an intercept. You see, for example, from 0 to pi, right? There's an intercept, and we have an asymptote right in the middle. You see, so every pi, there's going to be a period. But the vertical asymptotes start at every pi over 2. You see, every pi over 2 is an asymptote. Every pi over 2. And right now, I'm going to tell you why. And the x-intercepts will be in pi, right? So every pi, there's an intercept. And the y-intercept will be at y equals 0, 0. Okay? Okay, now, going back to unit circle. The tangent of theta is equal to y over x. Right, so let's go back right to the pi over 2 to unit circle. So the tangent is y over x, right? So the tangent of pi over 2 will be y over x, which will be 1 over 0. That's why, guys, this is undefined, which means at every pi over 2, there's going to be an asymptote. That's why the vertical asymptote will be at every pi over 2. Okay, now, to find two consecutive vertical asymptotes, for example, to find, right, two consecutive vertical asymptotes, like, for example, from negative pi over 2 to pi over 2, here's what you do. You let bx minus c equals to negative pi over 2, and bx minus c equals to pi over 2. So these are the rules that you're going to be applying. Now, let's do an example. Sketch a graph y equals to tangent of x divided by 2. So what do we need? We need to find one period, right, which would be bx minus c equals to negative pi, and bx minus c equals to pi over 2. So, right, so we don't have no c, guys. It's only x divided by 2 here, guys, right? So it'll be x over 2 equals to negative pi over 2, and x over 2 equals to pi over 2 on the right. But let me start with this one first, right? Here, we multiply both sides by 2, so the 2 cancels on the right side, so we have x equals to negative pi. Now, on the right side, right, is going to be x over 2 equals to pi over 2. Again, we multiply everything by 2, so x equals to pi. So we're going to have two consecutive asymptotes at every pi. Okay, and this is a graph that was there on the homework, right? So at every pi, there's going to be a vertical asymptote. Okay, and why? Again, why is it undefined at pi, right? So here, guys, so what we do here, guys, to find, right, we know at every pi is going to be a vertical asymptote. But how do we know that the graph goes in this motion, right? Or it starts low and it goes high. Here's why. I'm gonna plug in points. Okay, I'm gonna plug 3 points that are between negative pi and pi. So I'm gonna plug in negative pi over 2, 0, and pi over 2. That way to see how this graph is gonna go. So if we plug in negative pi over 2 for the x-axis, we can have the tangent of negative pi over 2 over 2, which will give us tangent of negative pi over 4. Because in the tangent of negative pi over 4 is equal to negative 1, which means a negative pi over 2, right? The answer would be negative 1. So you see a negative tangent of pi over 2, we got negative 1. At 0, right, tangent of 0 over 2 will be tangent of 0. The tangent of 0 will just be 0, right? So at 0, we got 0. Then at pi over 2, right, is going to give us pi over 4. The tangent of pi over 4 will be 1. So at pi over 2 here, it's going to give us 1. That's why we know the graph goes in this motion. Okay. Now let's sketch y equals to negative 3 tangent of 2x. Okay. So again, we have to find the two consecutive asymptotes. So 2x minus negative pi over 2, right? And also 2x, which will give us, right, we divide everything by 4. By 2, it will give us negative pi over 4. And on the right side, we divide everything by 2, right, and multiply by 1/2 will give us pi over 4. So this will give us two consecutive asymptotes. Okay, you see, at every pi over 4 is going to be an asymptote. Now, right with the table, what you do here, guys, if we plug in, right, so from 0, from negative pi over 4 to pi over 4, I'm going to choose 3 values, right? I guess how we do that, we're going to pick a value between 0 and pi over 4 will give us pi over 8. We're going to pick a value right in the middle from negative pi over 4 to 0 will give us negative pi over 8. That's why these are the points that they use. So now if you plug in negative pi over 8 where the x is, this will give us negative pi over 4, right? Negative tangent of negative pi over 4 will give us negative 1, and negative 1 times negative 3 will give us a 3. That's why they got these points here. Okay, and this is my graph that you're looking at. Because if you notice, the normal graph, right, for the tangent goes in this motion. It starts low and it goes high. But when it's negative, right, it starts high and it goes low. Okay, now let's graph the cotangent. Okay, this is the normal graph of the cotangent. Okay, which is similar to the one that we just did, right? The cotangent, I believe, is equivalent to the negative tangent. You have the same shape of graph. Now, the period will be pi. So here it says that, again, the cotangent will be x over y. So at pi over 2, or at pi, right, it's going to give us is negative 1, 0. So that way, at every pi is undefined. Why? Because negative 1 over 0 will be undefined. That's why, guys, at every pi, right, at every pi, like say negative pi, at 2 pi, 3 pi, 4 pi, and so forth, there's going to be an asymptote. Why? Because there it's undefined. Okay, now to find two consecutive vertical asymptotes, this is a property that we use, or the rules that we use. We let bx minus c equal to 0 and bx minus c equals to pi. Those are the properties that we use. Okay. Now let's sketch y equals to 2 cotangent of x over 3. So it's going to be x over 3 equals to 0, and x over 3, okay, so here x equals 0, right, because we multiply both sides by 3. On the right side, x divided by 3 equals to pi. We multiply both sides by 3, will give us 3 pi. So this will give us two consecutive asymptotes. Okay? And here it is, right? Here is 0, right? I mean, here's going to be 0. Let me see here. We're going to go from 0 to 3 pi, right? So here also, guys, it's supposed to be an asymptote here too, guys, right? But they don't have it because that's the y-axis. So at every 3 pi, guys, there's an asymptote, right? Because 0 to 3 pi is 3 pi. So at every 3 pi, we have an asymptote. And similar, guys, to know which points to use, right? Here's what we do, right? We divide 3 pi divided by 4 to find the 1, 2, 3, 4. I mean, those 4 points. Okay. Let me go back real quick. I mean, that's why, guys, from 0, right? From 0 to 3 pi, this will give us here. This will give us right, 0 is undefined. It's an asymptote. Then this is 3 pi over 4. This will be 3 pi over 2. This will be 9 pi over 4. And this is my 3 pi. Okay. So if you plug those in, guys, say you plug here 3 pi over 4 there, guys, for the x, right? And then you simplify that, guys, and then you multiply it by 2. That's what we got. The answer as 2. If we put here 3 pi over 2 where the x is, right? And then whatever we get, we multiply by 2. It's going to give us 0. In similar fashion, if we plug in 9 pi over 4 where the x is, divided by 3. And then it's going to give us a value. Then we multiply by 2, so it's going to give us negative 2. Okay? That's where you find those values there. Now comes the last two functions, guys. And again, this here, guys, I didn't really graph him. I just get you, copy the graph from the book. For the very same reason, guys, I spent a lot of time, like more than half of the workshop, trying to graph the sine and cosine, because in order to graph the cosecant, you have to graph the sine. And in order to graph the secant, you have to graph the cosine. Right, so in this case, again, right, so again, need to sketch a sine curve, right, because this is a cosecant, and cosecant and sine are opposite reciprocals. So need to sketch a sine curve, then at every x-intercept, there will be an asymptote. You see, notice here, guys? You see, this is, the one here, guys, is y equals to sine of x, the one in gray. If you notice, at every asymptote, at every x-intercept, you have an asymptote. Okay? For example, right, this is a sine wave. So at every pi, right, there's an asymptote. Asymptote, 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 and asymptote. So how do you graph, right? So once you graph the sine wave, then the cosecant, guys, the graph will be something like this, like in a U shape. You see, like it is here. And then whenever it touches here at the maximum, and it will never pass. Let me go back. It will never pass or cross the asymptotes. You see, guys, it never crosses the asymptotes. So that's how you graph it, guys. So this is not that hard to graph, but first, if you know how to graph the sine and cosine, then these will not be that complicated. Okay. Now, in a similar, so they want you to sketch the graph of y equals to 2 cosecant of x plus 4. So first, guys, we have to graph 2 sine of x plus pi over 4. And we repeat our process, guys, of what we did on the first few slides, right? We have to find the amplitude, we have to find the b, we have to, this will be like a horizontal shift, right? So we have to do all that. And after we do that, let me go back real quick, right? After we do that, at every intercept, we put some asymptotes at every intercept. And then where the maximum is, right, or the maximum of the sine wave or the minimum, we're gonna put like an image, right, like it reflects, but it doesn't pass the asymptotes, and that's how we graph each one of these. And same thing for the secant. For the secant, first I need to grab my cosine, and then at every intercept there's going to be an asymptote. Okay. Right, and this is a sine, the cosine wave, right? So at every intercept, there's going to be an asymptote, and here, guys, it's at every pi over 2. Right, then the graph for the secant will be something in this form, right? It'll go like this, up like that. Let me see if I can write here. Let me go back real quick. Let me see if I can use this here. Let's see, ink. You see, guys, it'll be something like this. Oh yeah, that's pretty good. But something like that, but it's going to be more perfect, right? It's going to be something like this. That will be your secant graph. I just want to do no more. Let's see. Oh, but you guys got the picture, right? So that'll be my graph. And then afterwards, if you want, you can erase the cosine graph, and it'll just be this right here, the one that I just drew. Okay, I don't know how to go back here. Let's go to previous. Okay, now let me go back here. Let's see here. I guess, guys, I don't know how to go back. I'm sorry about that. Let me see if I can do something here. Let me end the show, guys, and then no, just discard and just come back to the last slide here. Okay, so I can finish it off. Oh, I believe that was the last. That was the last slide here, guys. For this last slide, right? Again, we need to sketch the curve first. The curve for the y equals to cosine of 2x. And after that, guys, at every I'm here, guys, right? At every pi, guys, at every pi over 2, there's going to be an asymptote. Let me see here. Where is it at? At every pi over 4. For this one. Why is that? Because if we let 2x equals to 0 and 2x equals to pi, this is what it will give us, guys, right? It will give us these asymptotes here. I think it'll be at every pi over 4. Okay. Hey, guys, thank you, guys, for this, for being with us today. Let me go back to the host and see if you guys have any questions. Save it.
Thank you, Mr. Azasi. At this time, does anyone have any questions for Mr. Azasi on his presentation? While we wait for questions, we would like to go ahead and invite you for next week on September 12th for Happy Math Hour. We'll be going over Math 1332, Applications of Sets, and Exam 1 Review. For Math 2412, we'll be going over trigonometric, inverse trigonometric functions. I'm sorry, that one was a kind of a tongue twister for me. And then at the 1 o'clock session, we'll be having a Hack the Border overview and purpose with Dr. Servine. If there are no questions, we hope that you have a lovely weekend and see you next week for Happy Math Hour.